Hi. Thank you, everyone. So our next speaker has a long history with ZFS, and in particular, he's known for having ported ZFS on OSX. So our speaker is Jorgen Lundman, and he's going to talk about his journey of porting ZFS. Thank you, Jorgen. Thank you.
Thank you. So my name is Jorgen Lundman, and I work for GMO Internet in Tokyo, Japan. GMO started as an ISP, Internet Service Provider, in the mid-90s, then known as InterQ, later Global Media Online. So here are some of the companies, brands, and services that GMO now own. To be honest with you, I don't know what some of these do, but at least, well, we run ZFS or ZFS on the brands and services that my team is responsible for. Most of them are for the Japanese and Asian markets, but at least two, Konoha down at the bottom left there, and Z.com or Z.com have server racks here in California and a few other places around the world. So if you ever get tired of running Amazon VMs, feel free to try those too. Or don't, because I don't get a kickback. Anyway, enough of that. So today I want to talk to you about the OSX port of OpenZFS. And since I'm talking to a room full of developers, this presentation will be for developers to show how to get up and running with the OSX port as quickly as possible and how to do rapid development maybe. And a little bit also getting this presentation over with as quickly as possible. So this will be a developer speedrun. So with that in mind, I'm going to dive right in. There are some prerequisites. You need to get Xcode. It's a bit of a beast to download, but you are developers, so I'm sure you already have it, right? Then there's a few small tools, Automake, Autocom for that sort of thing. And the easiest way to install those is to paste in the one-liner that gets you Homebrew, and then paste in the one-liner to get you these tools. And both one-liners are on the OSX port wiki page. And then finally, we have SIP, System Integrity Protection. If you have your own kernel certificates, you could sign the modules every time you compile them, but that is a little bit tedious. So you want to at least disable the KEX protection. But since we are going to do some developing, you also want to disable the debug protection. And while you're there, you also want to disable dtrace protection. So to be honest with you, you must disable SIP entirely. It doesn't give you much. So especially since we're going to be loading our modules on a VM. So boot the VM into the recovery partition, run CSRU till disable, and then reboot normally, and you don't have to worry about SIP ever again. You'll have to get 2 repositories. SPL, Solaris Porting Layer Library. Brian, which one is it? Layer, yeah, good. And ZFS itself. If you place them next to each other on the same level, then you don't have to specify any paths to configure. And then like most open source projects, run the autogen to do the autoconf stuff, and then run configure, and then make, and do the same again for ZFS. And I'm actually going to do that right now. But it's a little bit laggy. I hope it will eventually catch up. Yay, okay. Right, can you read that? No? Well, you're going to have to squint otherwise, right? So let's all pretend that you believe I just ran these commands. So we have the 2 directories next to each other. I'm going to enter SPL, and I'm going to compile that. It's mostly just thin wrappers. It doesn't take particularly long, and it doesn't change very often. Basically, if there's a new major version of OSX out, then they might have some changes. So that took about 10 seconds. We're going to do the same in the ZFS directory. This will take a little bit longer, but it's not too bad. Once this is finished compiling, I'm going to copy everything over to the VM, which is probably an unusual way of doing it. I think most platforms would compile on the VM and then load it on the VM. Is that right? Yeah. You can do that. You feel free to do that. But when it comes to loading the debugger to connect to the remote kernel, you have to have the same object files on both machines. So I used to compile and load on the same VM, but there were a few times when I made a change that there was no way it was going to fail or panic, only to have it panic, and then you have to reboot and load everything in again, which is quite tedious, just to make it panic again. And there were a few times when it wouldn't panic the second time around, because why would it? So I kind of changed the way I work. So I compile on my host and then copy out to the VM, but whichever way you prefer to do it. And I will use just rsync, because this space is cheap and it's pretty fast, but you don't have to. You can use whatever you want, SCP or NFS mount maybe, or VMware shared folder, or Git itself, whatever you want to use, it's up to you. But at the end of it, I'm going to have the same object files on both machines. I wish this was running a little bit faster, because I'm running out of ad-libbing material here. And my brain only remembers the jokes that are wildly inappropriate. So I think I will, avoid doing that. But we are at the tail end of it all, so let's just, pretend it's going well. Can you read that?
Yeah. Jorgen, what do you mean by VM? Are you running a VM that has OSX on it, or are you using VM to mean something other than virtual machine?
I run VMware Fusion to run OSX on a VM. Okay. Just because, if you load your module on the box you're working on, it's a little bit tedious when it panics. All right, so we're at the tail end finally. So.
I don't know what OSX thinks about being virtual.
OSX, well, Apple didn't let you run it on VMs before, but now they do if you have Apple hardware. Yeah, so which I do. So yeah. Right, so that took 2 minutes, plus SPL maybe 2.5 minutes.
Reiterate the questions, please.
Right, I was just surprised he was heckling me in the middle of it. Right? All right, so I'm going to copy that over to my VM, which won't take long, I hope. Okay, and here's my VM. To be honest with you, when I'm working on ZFS myself, I will stay here and just SSH in and do the work, unless, of course, I'm working on a UI-specific problem or feature. But today I'm going to be in the VM just to show a bit more clearly where we are. Now, in most situations, you would be, well, with open source, you would probably run make install here. And you can do that. If you run make install, it will copy the modules where they need to go and all the binaries and so on, so that when you reboot, it loads it automatically. But we're not going to do that. Basically, make install adds maybe another minute. We don't have that time. And this is a speed run. So we're going to be running it from the source tree, which is what I like to do, but whichever you prefer. To help us run from the source tree, we will, rather, ZFS comes with 2 helper scripts. The first one is load.sh, which, well, loads the kernel modules. It chones it to root and wheel, which is a requirement by the Apple kernel. And I do that in /tmp just because if you did it in the source tree, then the next copy will break. So there's no specific meaning with using /tmp. But loading it this way means that if you reboot or panic, it won't load it again the next boot, which, can end up in a boot cycle. There is a slight detour here. About 2 versions of OSX ago, you could tail -f varlog systemlog to get the kernel messages, and life was good. Then Apple went and changed the way logging works. So now it is stored in binary database files. That in itself might be okay, but the problem is the command that Apple provided us to access the database is the log command. It's garbage, really. It's not very good. That's a bit strong, but it's not very good. In particular, if you run log stream, you can't pipe it to things like grep because it goes into buffered I/O, which is a bit of a pain. Now, there are many ways to solve buffered I/O problems, but I wanted to find a way that only used the base install utilities, which is why we have this thing here, script -q dev null log stream. And at that point, we can pipe to grep and so on. While I was here, I figured I might as well show that Logstream can output the messages from just ZFS and SPL. So I just left it as an example, and at the very end, I'm piping it to something just to show that I can pipe it. So I put it in the load script so I don't have to remember it every damn time. So I'm going to pop up a second window here, and I'm going to run the log stream command. Not very exciting. And then I'm going to load our kernel module. For something that should only show ZFS and SPL, it's rather verbose. Anyway, so we're going to load our kernel modules. Sorry, I'm going to do that as root this time. We're going to load our kernel modules. And you get this vague message from Apple where it's not entirely sure whether or not it loaded something. But that's okay, I guess. Over here, we have SPL starting up. And the first thing the SPL does is initialize KMEM. This is Jeff Bonwick's KMEM from Solaris, or Illumis, I guess I should say. We had some problems using Apple's memory manager in that we're not allowed to call half the functions. So we allocate raw pages from the kernel. So then we, of course, needed a slab allocator and some magazines and KMEM cache and all that stuff. So we figured, since we've already ported half of Illumis by porting ZFS, why not port a little bit more? So one of my developers, Brendan, did the port of KMEM, and that was actually quite easy. Nice, clean code, came over quite easily. The hardest part was, in fact, KMEM unloading, since on Illumis, unloading is rebooting, whereas we actually needed to unravel everything and free everything and give it back to the system to unload. So that took a little bit of time, but we got it in the end. We don't leak anything, as far as I know. We should probably look at the Apple allocator again, but to be honest, KMEM runs rather well for us. It sits in its own little world, but it gets pressure from the Apple kernel, so we can shrink and all that. And the KMEM from Illumis has some great debugging features with the red zone and the tagging and so on, and it's helped us find a few problems with memory management. Anyway, and then finally we have ZFS loaded up, as you would expect. Now the second helper script to run from the source tree is command.sh, which shouldn't surprise you, does the LD library path required for the binaries to be able to see the libraries. It's not very exciting, but that means we can run zpool like that and like normal. So we can go and create ourselves a pool at this moment. I'm going to call it tank on disk 2, not very exciting. And these pop up because I haven't done make install. Whereas if you do make install, it will know about the ZFS file type. The first thing you'll notice, of course, is that tank doesn't go into root, as in /tank. We place it in /volumes. That is mainly because if you want the UI to pay any attention to your mount at all, it needs to be in /volumes. But if you want it to be in /tank, just set the mount point. We only move it to /volumes if it's not set, just to be nice to the users. You can also set an environment variable. This we do in the ZFS tester environment because we didn't feel like changing hundreds of scripts to handle /volumes being the root. So those are two ways you can do it. Now I'm actually going to go and export the pool and then unload the kernel module. We can unload SPL as well if you want, but it doesn't change very often, so I wouldn't necessarily bother. So I'm going to go back to my command line, and I'm going to edit one of the files, vnops. You should all know vnops, I hope. And we go down to make dir. I don't know if you can read any of this, but it doesn't really matter. You'll just have to guess. And at the end of this, let's put in a call to panic. OpenZFS Summit. Voila. Right, so if you pay attention to the time, we'll save it, we'll compile it. You will have to go through the directory, so it takes, 10 seconds or something. There's some dead air there. Okay. And once it's finished compiling, we're going to copy it, and then we're going to load it again. So that is generally how long it takes to do a new version of ZFS and try it out. I'm sure other platforms is just as fast, I just don't know how. Anyway, we're going to go and import our pool again, and it's going to panic pretty much right away. That is because Spotlight is eager, I guess, it's a safe word. Oh, oops, we crashed. So at this point, I'm going to go and load the debugger. I'm going to point it to the debug kernel, which comes in the kernel debug kit, or the KDK, which is a download from Apple if you have a paid subscription. So if you want a copy of this, I'm afraid I can't really help you while I'm on camera. So let's load that up. And the first thing I'm going to do is tell it where my SPL binary is. And I'm going to tell it where my ZFS binary is as well. And this might not be the best way of doing it, but it's fast. And then we're going to connect to the VM. Now that we've connected, you can run, for example, the system log. I'm not going too fast, no? Okay. Which will just dump the kernel message buffer. Not very exciting in this case. Or run the panic log command, which will give you the panic log, I guess. Which includes, of course, the reason that we panicked and the stack that we were in when we panicked. But when it comes to the panic stack, you can just run backtrace to get the full stack, and we can walk up until we get to our source line, which is quite nice. And at this point, we know we have a Z node, or a ZP, I guess you call it. So we can have a look at the ZP and inside it. And scroll past that. And we have the fields that I'm sure you're all familiar with, I hope. I also know we have a vnode at this point, or rather, I think I have a pointer to a vnode. So we have to go like that to see inside the vnode. And we can see the use count is 1, IO count is 1, and use count is 0. Remember that we can see inside the vnode, because that comes into play later. This is useful for panics and crashes and so on, but the situations where we have deadlocks, for example, you can NMI the host, or non-maskable interrupt, your VM or hardware, and then connect the debugger. And in that case, you can run something like show all stacks, which will dump all the kernel stacks in one go. I won't do it now because, we don't have that time. You can easily then search for which stacks have ZFS in it and see that which ones are blocked, perhaps waiting on a mutex. And with the case of mutexes, you can, of course, take a look at, whoopsie, you want me to spell that right? It looks like this. This isn't, the SPA namespace lock isn't held at the moment because owner is all 0. But if it was held, we can then use switch to act with the address and then do backtrace on that thread and try to figure out why it hasn't returned the mutex like it should. So that's deadlocks, but you can also use it. For example, Sean, one of my developers, he had a double panic situation where it would trash his stack whenever he ran the code. So he NMI'd his host, set a breakpoint on panic, and then triggered it, which I thought was quite neat. So he can get the pristine stack before it got trashed and then fix his problem. Which of course means that if you have old or new code that you want to debug, you can NMI, set the breakpoint, and then single step your way through the kernel, which I think is quite powerful. I don't know if any of the other platforms let you single step through the kernel. Good, excellent. So anyway, those are good things. Once you finished, you fixed your bug, whatever, you can then, of course, reboot your VM. But I'm not going to do that. Well, I mean, I am, but I need a memory, so I'm going to just shut it off. And I'm going to go power off. Right. So, OSX port. That's our homepage, OpenZFS on OSX.org. We're, of course, on GitHub. What the? Our latest version is 1.6.1, we consider it stable. There is a 1.6.2 release candidate out for High Sierra, because they changed some things. And I believe we're working on a 1.7.0 binary release right now. I think Joe is working on the package right now. But that doesn't really matter if you're working from the GitHub or the repository. We internally to the team, we check OSX 10.8 to the latest, 64-bit. If you really wanted to, you can go older or 32-bit, but we don't bother. We upstream directly with OpenZFS repository. So whenever Matt approves a new feature or a PR or a commit, just a few hours later, we'll pull that in, or rather cherry pick it in. And thanks to time zones, technically we get all the features first. So, you know, pretty sure that's how time zones work. In terms of ZFS itself, we're quite complete command line point of view. What we are missing some UI integration. Like if Finder has a way you can set ACLs and so on in the GUI, but that does not translate into ZFS at the moment. We have boot support. A very valid way to do it is Z-volume with HFS on it and booting. You get full compatibility. You can also boot a data set, but there are some minor incompatibilities there, like fonts don't work. So if you don't mind fonts not working, that works, you know. But yeah, so we need to fix that, and it's been quite a few months now we haven't been able to figure out just why. Now, if you were to look at the OSX port, there are some differences. In particular, many of the kernel structures, UIO, vnode, and buff, are opaque, so you cannot see inside them when you're compiling. Of course, the kernel debugger or the debug kernel will let you look inside vnode, so it doesn't actually impede you debugging, which is nice. But while you're compiling, there is no looking inside. We also cache names in the Z node, which is a bit unfortunate, but again, Spotlight likes to call vget a lot on the ID, and then it calls get attributes, asking for the name. So yes, on OSX, you can get the name from get attributes. This was a little bit slow and painful, so at the moment we're caching names, but we should probably revisit that at some point. Maybe there's a better way to solve that problem. And then finally, we don't call the VFS layer with locks held, which generally just means we delay creating the vnode until the transaction has been committed. But there was only like 5 places in the code that we had to make the change, so that was okay. And more importantly, all our deadlocks disappeared overnight. So it was actually a good thing in the end. And I'm wondering if other platforms should try it, if you have deadlocks, I don't know. Right, so part 2. We're going to descend into madness, and things might go a little bit wrong here. But let's try. So then, what about the Windows port? And can we use what we learned on the Windows port? I'm going to go to another VM, would you believe it? This might be a little bit laggy because there's not much RAM on this machine. Is it loaded? Oh, it's loaded. Windows 10, 64-bit. We're going to look in Dev Studio. Can you read that? It's tiny. It is rather tiny, but I can't change the font size. So over here, it says kernel and userland. Believe me, it does. And inside kernel, we have SPL, which has the familiar SPL source files, and quite a few more, I assure you. And then, of course, we have ZFS with the familiar ZFS source files, and quite a few more, I assure you. And if you skip the kernel and go look in the userland, swapping a little bit. We have libraries, all the familiar libraries that you would expect to see, and quite a few more, I assure you. And then finally, we have command line, where you have 2, because that's all you get. That's all you need, really. Sorry, it's a bit hard to read that, but yeah. Okay, so let's take a look at a command line here. This is standard Git for Windows Bash shell. So it's a standard Windows utility. It's nothing to do with Ubuntu for Windows Bash shell. So I can run, dir. Well, I guess both of them can. But anyway, So if you take a look at the produced binaries, we have the sys file, which is the Windows kernel module, if you will. And that comes with an INF file, which you use to install the sys file. And then finally, the two binaries. Yes, that means those libraries that you saw earlier are all compiled statically. I'll go back and change that sometime, maybe. It's not so important. And if we have a look at the kernel message buffer here, is it too small to read? We have SPL starting up as before, and it initializes kmem. Yes, this too is running Jeff Bonwick's kmem. He'll just have to find some way to live with that. And then finally, we have ZFS loading up as you would expect. So let's run some of these commands. Oh, this shell command line is running elevated, as in run as administrator. I didn't want to get bogged down with the whole sudo for Windows problem. So, standard output, what do you expect? We can then try to go and import a pool. I should mention that these commands are rather verbose, with a hint of desperation. So we're going to get some walls of text here. We run import, we get boom, right? And the first problem is Windows does not handle EFI partitions at all. So I had to use libefi in the libzfs library to handle it. But we can find a pool called boom. So let's try to import that. We'll get the same wall of text again. But the most important message here is that boom was mounted on d:. Yeah, d:. Now, there are some errors afterwards, but that is because my libshare library has been gutted. There's no sharing at the moment. So we can then run the normal Z. I actually tried to get rid of that .exe because it looks a little bit wrong. But it turns out that that problem was a little bit bigger than the 5 minutes I wanted to invest into it. So maybe in the future. So we can run the usual pull commands, not very exciting. List, get all the properties, and of course status. Here you will notice that the device name has the partition offset encoded in the beginning of it, followed by the partition length. Yes, it's a bit of a hack, but it is also interesting to note that the only place that we open the device name is in VDEV disk. So it was really easy to parse those two numbers out before opening the disk. And the only place we issue I/O is in VDEV disk. So it was really easy to add the partition offset onto the start I/O offset. So it ended up being, even though it is a hack, it ended up being quite pleasing. So it gives me a bit of conflicted feeling there. But I think that's quite normal for my code, to be honest. But, you know. And of course, we can run the ZFS command, I hope. Not very, you know, get, that's the usual, get all the properties. You'll notice it's using LZ4, but otherwise a pretty standard pool. But anyway, it's probably more exciting to have a look in Explorer. Boop. So over here on the left, we have boom as d:. And of course, we have some test files and directories in there, so we can go inside a directory and go back out again. And we have a text file that we can load and open up in Notepad. Hello world. Yay. We can drag a PNG from the desktop into our pool to show that we can write. And of course, open that PNG into photo. Well, if you can read Japanese, it says photo, trust me. And you'll get the picture of the family cat, I hope. Yeah. Right, so. Windows version. What about the Windows port? We have, it doesn't really have a name yet. Okay. It doesn't really have a name yet. There's a story to that, but anyway. The current version is alpha, or it wants to be alpha when it grows up. You know. It is for Windows 10 64-bit, not because any source is specifically for Windows 10, but that's the only VM I have. So It's the only one I tried. But I am fairly confident it will also compile on Vista and 8 without much change. It comes with free panics. So only run it on test VMs, on test pools with test data. I don't want to spend the rest of this summit fixing people's Windows boxes. In fact, I never want to fix people's Windows boxes, just to make that clear, right? It is missing large bits. In particular, the user ID and group IDs aren't connected to anything. So you can chown all you want. It's similarly for file permissions, but some are supported there. Certainly doesn't have any code for ACLs or extended attributes. But the core is working. The VDOs are all working. The mirrors, RAID Z 1, 2, and 3. Compressions are all there, including LZ4, as you saw. Checksums are there, including a Donner and Skein. Is that how you pronounce it? Encryption is there in that the library is compiled like checksums. I just haven't pulled in the commit yet. It's just a matter of cherry picking it. DDoP is there. The tasks queues are spinning up all the threads, so that's all running as you would expect with the convars, and Arc reclaim thread is running. So everything is ticking away as it should. Now it does need some resources, I must admit. Usually that means money, and I like money, but it developers would be nice too. When I started this, I didn't know the Windows kernel at all, and I still don't know the Windows kernel. So even if someone doesn't want to commit to it full time or anything, but if you just want to look at the code and go, maybe you should call this function or that function, because Windows has a lot of misinformation out there. It's hard to know exactly, because of the legacy problem. Like XP is your first hit, right? But you don't do XP calls anymore. Anyway, so knowledge and direction would be nice. I don't want to do it all on my own. A couple of thanks. Work, obviously, for looking the other way when I get crazy. Let's pretend that that's what's happening. Who knows? I just want to mention also Microsoft have Windows 10 developer VM disk images that you can download. Come with 90-day license and Visual Studio installed. Because if this project had to start with me downloading Windows, installing Windows, downloading this Visual Studio, and then installing Visual Studio, it wouldn't have happened. That's the straw that broke the camel's back, that first straw. Well, bad analogies aside. Anyway, that leaves me with the final landing page where I say thank you for letting me talk today. I assume there are no questions. Oh, damn.
How long did it take you to port it on both OSX and Windows?
How long did it take me to port it on OSX and Windows? Interestingly enough, actually, let me answer that a little bit differently. I found OSX to be harder to port, but not because of OSX's fault. Basically, when I started, I didn't know ZFS, and I didn't know SPL, and I didn't know the Apple kernel. So there was 3 unknowns, and it was quite hard to guess where the solution should be, right? Whereas with Windows, I knew SPL very well, because I wrote most of it on the OSX, and I know ZFS fairly well. I just didn't know Windows kernel. So OSX, it was more like a year until we had the first pool import. Whereas Windows, I started in February, and I finished in July. Yeah. There were some surprises along the way. You discover a lot of things. But anyway, that's another question. Any other questions? Yo.
From a performance perspective on Windows, have you had any tests that you do?
From a performance perspective, have I tested it on Windows? No, not really. This is more of for me, it was a proof of concept. If you'd ask me why, I can give you a pretty long answer as to why I tried to port it. So no, I don't know how it performs, but it does okay with the little tests that I do. But it's hard to tell when it's a VM, and Windows is always updating. So yeah. Right, any other questions? Sure. Have I had any interest or comments from Apple? No, neither of them. Absolutely nothing. Yeah. The users, yes, but not from the actual people. Yeah. Sure. Yeah.
Is the macOS bootability ready to be used in, I don't know, a trustworthy environment? And do you see encryption coming to it?
Is the OSX version boot availability, is that a viable option? And will encryption come to OSX? As for booting, there are quite a few users out there who are booting with the Z volume. And yes, that runs rather well. And we're even trying to make it compatible enough so that the OSX installer will see the Z volume as an option. But again, there are some hidden things that we're not sure what Apple did, so we're fighting that a little bit. As for the encryption, that's already in there. Yep. Anything else? Am I free to go?
One more question.
Oh, okay, yeah.
No, I mean, we have time for one more.
Yeah, come on. Go on, bring it. Sure.
Why did you port to Windows?
Damn. Okay. Why did I port it to Windows? I guess I wanted to challenge myself. I think most people here kind of knew that it could be done, in that like X3 has already been ported to Windows, and X3 uses the same VNOPs as ZFS. It's not like ZFS has these advanced secret VNOPs, right? So in that sense, it could be done. It's more of a question of perseverance and sanity. I didn't know if I could do it, right? I didn't know if I was up for the challenge, but I wanted to try. So I just started and see how far I could get, basically. And every time I came across maybe 3 brick walls, and I almost gave up at that point, but found a solution and kept going. As for whether or not it should be ported, it's not really something I want to touch. I just want to see if I could do it. Should you run ZFS or Windows? Yeah, that's someone else's problem, I guess. Thank you.